This video is brought to you by Squarespace.
It's the year 1850 and it's the dawn of a new era. Steam engines are commonplace, cities are full of factories, and the world is in the full swing of the Industrial Revolution. And with it, the time has arrived for the water train. Known technically as a chain boat, this river craft was the first marriage between the almighty steam engine and the humble river barge. No longer would captains of industry be shackled by animal power or subservient to Neptune's command of the waterways. This incredible type of machine would put itself up and down waterways along a track, sometimes faster than the current, much like a locomotive that would come to dominate the land. But unlike land trains, in one fell swoop, the entire world of chain ships would vanish in only 50 years. An era so brief that many viewers watching right now may have never even heard of these craft. So in today's video, we ask ourselves, how do these machines actually work? How do they move around a bending river? What happened to them? And why will we never see water trains ever again? Imagine you're a coal baron and you need to get your precious fuel from the mines to the factories. How do you do it? In the early 19th century, trains that ran on land were rudimentary, slow, and were limited by where you could lay the track. And sometimes the distances involved would make the cost of a railway line to be eye-gouging. Shipping by water, however, was significantly cheaper. You could fill up a barge with a ton of coal and other resources, float the barge down the river with minimal effort, and not worry about the distances involved. However, the only way to get the barge back up the river would be by animal power, a series of noble steeds to pull it against the current. In some rivers in Europe, the current was so strong that rivers were impossible to navigate, and thus resources up in the hills were locked away. That would all change with the invention of the steam engine. By putting a steam engine onto the barge, it would move the source of power from the land to the craft itself and allow it to apply power against the raging current without having any on-land infrastructure. And the ingenuity of this design was how simple it was. The onboard steam engine would simply crawl itself along a chain that would run along the river's bed. Multiple barges could be tied together or operate on the same chain at the same time, and thus a water train was born. But let's get into the nitty-gritty of how this all worked.
This chain boat technology was cutting edge for its time, but as new technology developed, it slowly got obsolete and replaced. It's just like trying to get a business up and running using a phone book or business cards, instead of, say, using a Squarespace website. Yes, that's right, a website built with the new Fluid engine from Squarespace, today's video sponsor. Now hold your horses because I've got a preview of the next video right here. There are hundreds of templates to choose from Squarespace, plus ones that have an online store all set up for you. All you have to do is just add products, or others that can launch a business idea in an instant so you can get going faster than a chain ship. In fact, it's the exact thing that I use for my own store, foundandexplained.shop, for all your cool merch. Now, I bet you're sitting here watching this and like, I love you, Found and Explained, but what has Found and Explained done for me lately? Well, I haven't come to you empty-handed. Not only can I give you 10% off your first site and domain at www.squarespace.com/found, anyone else who clicks the link also gets my gratitude and thanks for making everything I do here possible. So thanks again, and thanks Squarespace.
These boats, in particular the Bavarian chain boat that's on screen, were specially designed to optimize efficiency and maneuverability under challenging river conditions. Their hulls were symmetrically shaped, sitting almost level with the water at the bow and stern, which minimized the power required to lift the tow chain onto the bow and allowed for a reduced draught. The whole thing was very low. This design was particularly advantageous for navigating shallow rivers with fast currents, which were common across Europe during this era. Chain boats typically had a flat, shallow draught when unladen, it could be as little as 40 to 50 centimeters, allowing them to operate even during the dry summer months when the river water was extremely low. But even fully laden with coal, the draught only increased slightly to about 70 to 75 centimeters. The deck of these boats was uniquely contoured unlike any other boat, low at the bow and the stern but higher in the center, which facilitated the installation and housing of the steam engine. These vessels varied in size to suit different river conditions, with shorter chain boats ranging from 30 to 40 meters in length to 5 to 6 meters in width were found to be more maneuverable, making them ideal for navigating narrow, winding rivers. The other hand, longer boats measuring up to 55 meters long and 10 meters wide were better suited for deeper rivers where the deeper water required more power to lift the heavy towing chain. The construction of the chain boats involved either iron or wood, materials that could withstand minor impacts on the riverbed but were still light. Safety was a significant consideration as the hulls were compartmentalized with several waterproof bulkheads, which helped prevent the boat from sinking in case of damage. Below deck, these boats were equipped with a steam engine, coal bunkers, and crew accommodations, ensuring that all essential operations could be managed on board. A defining feature of the chain boat navigation was the laying of the chain loose on the riverbed, which could extend for hundreds of kilometers. That's right, a single chain, hundreds of kilometers along a river. This heavy chain, weighing around 15 kilograms per meter, relied on its own weight and the natural contours of the riverbed to anchor itself, providing the resistance necessary for the boats to haul themselves and their barges along, but also not get swept away by the river itself. This system was only anchored at both ends of the route, allowing continuous movement along the chain path totally impeded. However, the major challenge with this chain system was the tendency of the chain to straighten, pulling to the inner side of a river bend. To address this, the chain boats were equipped with large, powerful rudders at both the bow and stern, exceeding up to 4 meters in length, which were controlled from the deck. These rudders, combined with maneuverable booms that extended well beyond the deck, helped manage the direction and angle of the chain, preventing it from striking the rudders or drifting the entire boat off course. The booms also featured a chain interceptor, which would grab the chain if it would snap, preventing it from being lost in the river, which you can imagine would be very expensive to repair. And you're probably wondering to yourself, how would the chain actually snap? Well, that's because the engines on board these bad boys were seriously powerful. The first generation of chain ship had a chain driver. The chain would run over the wheels located on the side of the vessel, but this was a problem as it would list the ship sideways. Thus, for the next generation, the chain was always located in the middle of the vessel. The second generation employed a drum winch. The chain would be wound several times around 2 tractional drums in the center of the boat, giving the chain ship plenty of grip. However, this put a ton of pressure on the chain itself and would snap constantly. It wasn't the chain itself overloading on the vessel, but because it would wrap around the first drum more times than the rear drum, thanks to the increased friction. This imbalance would pull the drums tighter, but since they were so big and heavy and couldn't move, the force would echo along the chain and simply rip it to shreds. These constant chain breakages would lead to the third generation design, the chain grip wheel. The idea of this mechanism was to use just one drum or wheel for the actual drive and not to wrap the chain all the way around it several times, but to only wind it partially over the wheel on the top. The design would engage the chain securely without letting it slip. It would work with a different chain thickness and lengths of chain link, and it would also work independently of the chain's orientation, whether or not it came from the side of the boat or straight on. Even if there was a knot that had somehow formed in the chain, the design was able to respond without a problem. This third generation would be revolutionary and would be spread throughout Europe, taking the rivers by storm. The chain wasn't the only method of locomotion either, as the boat did need to disconnect to let other vehicles pass, or simply if it needed to get off the track for its own purposes. This was done by a pair of water turbine side-mounted thrusters. Water was sucked in through two rectangular intakes in the side of the chain steamer's hull, where it then flowed through the turbine inside. The turbine accelerated the water and forced it through the rear-facing outlets in the side of the hull. The outflow jets of water propelled the boat forwards, but it could also be reversed by just swinging around the reversing element, so the water was forced in the opposite direction. But the water in the turbine was always flowing the same. You could actually switch one side and keep the other one facing rearwards, and the boat could be turned around. So, what exactly happened? Why don't we have water trains today? Chainboat navigation marked a significant transformation in inland shipping during the Industrial Revolution, becoming very prevalent in the second half of the 19th century across Europe. This chain drive mechanism was particularly effective given the relatively low-powered steam engines that were available at the time. But the thing is that this design was not just a technical advancement, but also a practical response to the challenging conditions of river navigation prevalent then. Many rivers were either too shallow or too fast-flowing for paddle steamers to operate effectively. Consequently, chain boats became numerous throughout European rivers that suited this, but it wasn't that popular in America. But as the 20th century approached, chain boats faced increased competition from more powerful paddle steamers, thanks to the advancements in steam engine technology, as well as the canalization of rivers, making navigation easier and far more efficient. The development of river systems and competition from road and rail further reduced the profitability of chain boat that were now seen as incredibly inflexible. This shift underscored a dramatic period in maritime technology where the innovations rapidly supplanted older methods, reflecting the relentless progress of industrial technology. In the end, the chain boats or the water trains were only used on particularly difficult sections of rivers until land trains could supplant them completely. This video was put together and produced by none other than our team member Jared, who really wanted to cover this topic, and I wanted to make this as a special thank you for all of the hard work that he has done for the channel. It would not be the same without you, Jared, so thank you so much.